Hi there, I'm about to go through how to get the answers in the 2021 organic topic test for our Tauranga Girls College Level 3 Chemistry. Here, the first one, question 1A, we are first looking for the longest carbon chain. So we've got 1, 2, 3, 4, 5, 6. Try to include the functional group in that carbon chain, so it's going to be a hex. Then we want to look at the main functional group, which is anoyl chloride. Now remember, as soon as we get an anoyl chloride, I don't think I'm going to keep writing these. Oh, that's fabulous. As soon as we get an anoyl chloride, we know that is carbon 1. So therefore 2, 3. So both of these methyl groups are of carbon 3. So we're going to have 3, 3, dimethyl, di meaning 2, hexanoyl chloride. Wow, that's beautiful. And then I'm not even going to write the chloride. Right, so the next one we have to draw. So we've got something ill, something anoate. We know that is an ester. Okay, so I always start with the anoate bit. So I'm looking for 4 carbons. 1, 2, 3, 4. And on that carbon, I'm just going to get rid of this here. And on that carbon, we have our anoate bit, which was a double bond to O, and then our single bond to an O there. And then 2 carbons on the other side of the functional group. 1, 2. Now I'm not going to draw the H's in because obviously this drawing is horrendous. I'll just put the sticks in. Common errors, just put a stick in there, or some people like putting sticks on their oxygens. A bit weird, but hey. And make sure your terminal carbons always have 3 hydrogens. Boom. Okay, next one here we've got to name. So again, we're looking for our longest single chain. 1, 2, 3. So we've got a prop. Oh, look at that beautiful line. Don't mistake a Cl for a C. That's a common mistake as well. So we've got a prop. This is an aldehyde functional group, so we're propanal. Remembering that like the acyl chloride, the aldehyde is always on carbon 1, so it does not need a number. So that is going to be carbon 1. So therefore our substituent, our side chain, is going to be a 2-chloro. So we're looking for 2-chloropropanal. And lastly, pentanamide. Pent, we've got 5 carbons. Oh, this is fabulous. 4, 5, beautiful. And amide or anamide gives us O, NH2 on the same carbon. And again, that would be carbon 1 if we had to name it. Don't forget your hydrogens. 1, 1, 1, 1, 1. 1 and nothing on there. Commonly you would have to get 3 of those 4 right to get a little a there. I'm sure we all did that. Right, number 1B1, we have to complete the following reactions. So there's 2 functional groups in here, which makes it a little bit more challenging. We've got an oxidant there, so we're looking at what can be oxidized. So both of these can be oxidized. The only things that can't be oxidized are tertiary alcohols. So we're going to copy the carbon chain, 1, 2, 3, 4, 5. And then we're going to oxidize both of those groups. And in the absence of any other information, we're going to fully oxidize them. So that's going to become a carboxylic acid. And that's going to become a ketone. And so the only other things we need to do is put all our hydrogens in. That was a little bit tricky because there was 2 functional groups in there. No H there, no H there. Okay, next one down. I'm just going to make my line thinner here. Next one down. Again, we've got 1, 2, 3, 4, 5. This is an oxidant as well, but it's a very weak oxidant. So remembering that the difference between these 2 is because this is so weak, it will only oxidize an aldehyde. So if we draw again the same carbon chain for, oh my gosh, this is stunning. So we're going to oxidize this group to a carboxylic acid, but we are not going to oxidize the alcohol. So that will just stay as an alcohol group. Keep our hydrogens on there. It might make you laugh to know that I'm getting a sore arm from doing this. Okay, so that was a bit tricky. So we did need to know about the difference in strength. So Benedict's and Tollens are weak oxidants. Permanganate is stronger than them. Dichromate is stronger again. Right, compare and contrast these two reactions. So remember, we want what is the same and what is different. So we want the type of reaction that occurs. Obviously, that's going to be a compare. Both reactions are oxidations. We want a description of the changes observed. So this is going to give us, we want to explain what we would see. So in this one, our permanganate is purple. And because it does react, that is going to go to colourless. Remember, it's the permanganate that's changing, not the organic molecule or solution. Oh, that's really bad. So this is going to be a contrast. So in reaction 1, purple permanganate will decolorize to colourless, whereas Tollens, which starts off colourless, oops, that's bad spelling, colourless, will, because it does react, produce a silver mirror. So this is a contrast, so we're going to make sure we've written the first and the second colours for each of those reactions. So that's that one done, and that one done. Reasons for the difference in the products. So I've explained that as I went through, and that is that this is a weak oxidant and will only oxidize aldehyde, whereas this is a stronger oxidant. So therefore, this will oxidize alcohols and aldehydes. Boom. Okay, so in both, this one, whereas that one. So one compare and 2 contrasts. So that's the end of that one. So now we're on to part C. Complete the following reaction scheme with the formula of the intermediate product and the reagent needed for the second step. So what's happening in this, if we take a quick look, is we're going from the functional group, the carbon-to-carbon double bond being between carbons 2 and 3, to going to be between carbons 3 and 4. Now obviously if I was going to name each of these individually, I would name both of them with this double bond between 2 and 3, but we're just showing in this case that the double bond has moved. So the only way we can move a functional group is to do additions and eliminations and take major and minor products. So here, if we add HCl, obviously that is going to add across the double bond here. So we're going to copy our original molecule. Okay, and that's a CH. Sorry, this is really bad. Okay, so now we come to our double bond. Oh, I've done that wrong, haven't I? Okay, CH. Sorry about that. And okay, so now we come to our double bond. And we have to choose whether we're going to make the major or the minor product. So what I'm going to do here is I'm going to stop and remind myself of my 2 options. So I can either put the hydrogen here and the Cl here, or I can put the hydrogen here and the Cl here. So I'm going to need to follow Markovnikov's rule here and talk about major and minor. And obviously I'm going to want the functional group here so that I can then move things to the left along that group. Now, even if you can't understand this, you would just try it. And if you put it around the other way, hopefully you would then see that this didn't work. So this is the substance we want here. We want to add it. So we're adding the hydrogen to the previously double bonded carbon that had more hydrogens to start with. So this is actually our major product. Now, how do we then go to this substance here? So if we remember, I'm just going to use a different colour here, we're going to then need to eliminate. So we're going to eliminate here, and when we eliminate, we remove the functional group and the hydrogen from an adjacent carbon. So we can either remove these two or we can remove these two. And obviously if we want the double bond to be here, it's these two. Oh crikey, that was bad. Can I just undo that? Yeah, it's these two that we want to remove. Okay, so that means we did the right thing by putting the chlorine on this atom here. If you still don't get it, try putting the chlorine on this atom and then see if you can get this thing over here. Now the only other thing we need to do is to put the reagent in, and that is going to be KOH, and the important thing is that that is alcoholic, or an alcohol, and that will give us our product there. Right, in each of the steps there are two possible products. Give a reason for the two products and explain why the resulting product is the most likely to be formed. Well, obviously we're talking about major and minor, but it says reason for. So why can we get major and minor in our addition here? There are two things we need to do to get major and minor. We need an asymmetric reagent and an asymmetric alkene. Okay, two asymmetric things. So here we're adding H and Cl, and here we've got double bonded carbons which are not the same. This one has an H and a CH3, this one has a big group and a CH3, i.e. asymmetric. When we are doing elimination, so that's addition, when we're doing an elimination to be able to get two different products, all we need in that case is an asymmetric haloalkane in this case. So this word asymmetric is becoming quite important. Okay, and this is asymmetric because the carbon that has got the functional group has got two adjacent carbons and they are not the same as each other. Right, that makes this asymmetric here. So both of them are asymmetric, so those are the reasons that we get two different products in each of them. Why is the resulting product most likely? Well, that is asking us to explain why we're getting the major product. Major product is the most likely one to form. This one's the major because the hydrogen is added to the double bonded carbon with most hydrogens. Rich gets richer. This is the major because in fact, there is no rhyme or reason for this one being the major, but usually we would say that it's the poor getting poorer. So the adjacent the adjacent carbon with more hydrogens, with fewer hydrogens would lose another hydrogen. I'm sure there's a good reason for why this one could be the major, but I don't know what that is, so there you go. Oh, no I do. It does follow the rules. Golly gosh, sorry. So it's because of the way I've drawn it, isn't it? Because this carbon here has two hydrogens and this one only has one hydrogen. So this is the major product. My apologies, it does follow the rule. So there we go. That's why are they both major. We have to talk about the rich getting richer and the poor getting poorer. Oh, we've got one more here. Complete the reaction scheme by writing the structures for the products of this reaction followed by further reaction. This is a little bit tricky, this one. I'm not actually quite sure what we ended up doing with this reaction product, but the simplest answer is if we redraw these two H's so that we've got one up and one out, we can do a condensation reaction where we remove the HCl and we join these together. So then we just copy it down. Okay, so it's just a normal condensation reaction here. Condensation reaction is one that we should really know how to do. I'm not getting better at driving this, am I? Oh my Lord. C double bond to O. Right, so now we've cut out that, so now we're going to go straight to the NH And then we just copy the rest in, CH2, CH2, NH2. Now, the issue with this question, it's a bit of a nasty question. It's not an old NCA question. It's an old school exam question that we didn't write. And what could happen is that this is another NH2 group here. So this could actually form another condensation reaction with another molecule of that. So if this did happen, of course, you'd have pretty much have 2 of these molecules for every one of those. And then it would look like this. Just rub that out as well. Okay, and I'm just going to pick a different colour. Okay, so I'm just going to redraw that H there, and then you'd have a condensation reaction again, and now that's that group there, and now we're going to go that way. So we go CH2. I'm not going to be able to fit this. CH. Oops. CH2. Okay, so that's the actual right answer. That's a bit mean, to be perfectly honest. When you're then adding bromine, basically you're doing an addition reaction. You've now got 2 double bonds if you got that right, or 1 if you didn't. Now, I'm actually not expecting anyone to get this fully right because it's really a bit nasty. So let's just show what would happen for this addition. Everything else should stay the same. You just get those 2 BRs on those 2 carbons there, and then the H stays there, and then everything else should just be copied down. And if you did it right, if you got it right, well done you, you're amazing. There should be 2 more BRs there. And that's the end of question 1.